At first, everything seemed totally normal in the early hours of June 18th. But then, a massive, state-owned Gazprom refinery complex right in the Kapotnia district of the Russian capital suddenly erupted into flames. Welcome back to Air Flight Space, where we explore aviation stories, air safety investigations, industry developments, and the lessons shaping modern flight. Today, we're investigating a huge aerial strike that somehow bypassed one of the most heavily defended airspaces on the planet, and we're going to look at how a completely new global manufacturing strategy actually made it possible. All right, let's dive into this.
Now, to really wrap our heads around the gravity of this event, we have to look at the sheer scale of the operation. Early that morning, dozens of one-way attack munitions breached Russia's air defenses. And get this, the Russian Defense Ministry reported that they tracked over 1,000 incoming attack drones and several cruise missiles. 1,000. That is a massive saturation tactic, literally designed to just overload radar systems and exhaust interceptor stockpiles. Footage from the ground actually captured air defense missiles frantically trying to intercept the threats. But as you can guess, some found their mark, and the results were devastating.
But the objective of this strike wasn't just about physical destruction, right? It was a highly visible strategic message. Kyiv immediately confirmed the operation. Ukrainian President Volodymyr Zelensky talked about the bombardment directly, saying, "Our long-range sanctions once again reached the Moscow region. This is a fully justified response." Notice how he framed the destruction of energy infrastructure not just as a military tactic, but as a kinetic economic sanction against state-owned enterprises. Keep this phrase, long-range sanctions, in mind because this whole concept relies completely on the specific hardware we're about to analyze.
All right, moving to Section 1, breaching the capital. Let's look at the immediate aftermath on the ground.
Investigators looking at the scene cataloged a massive systemic disruption across Moscow. One drone scored a direct hit on a huge storage tank at the Gazprom refinery. The subsequent explosion was so violent, it actually blew the tank's massive circular cap straight up into the air. But what's truly surreal is how people on the ground reacted. Civilians actually reported feeling a fine, light drizzle of oil falling from the sky right after the attack. Wild, right? Fires raged through the complex and even spread to nearby residential buildings, though it's still kind of unclear if that was from targeting errors or just falling debris from mid-air intercepts. Plus, the logistical impact was absolutely staggering. Authorities had to dispatch half a dozen firefighting helicopters, and Moscow's 4 commercial airports were temporarily shuttered, causing over 500 flights to be delayed or canceled.
But here is where investigators noticed something highly unusual about the debris left behind. Here's why this matters so much. The central mystery of this deep strike was that absolutely zero Western-made weapons were used. Literally none. This is a crucial detail. See, Western allies have long restricted Kyiv from using donated long-range missiles to strike deep into Russian territory. So, to pull off an attack of this magnitude on Moscow, an entirely different technological pipeline had to be at play.
Which brings us to Section 2, the indigenous drone fleet. Basically, to bypass geographic restrictions, you got to build your own weapons.
What's truly remarkable here is just how fast Ukraine's domestic aerospace sector has matured. The success of this Moscow mission proves they've made a massive leap in long-range strike capabilities. If you look at the hardware, footage indicates they used numerous FP-1 kamikaze drones. These are made by a Ukrainian firm called Firepoint, and they feature an optional wing-mounted fuel tank that pushes their extended range to over 1,450 nautical miles. That's huge. In fact, just hours after the Moscow strike, Firepoint was literally showing off footage of the attack at their booth at the Eurocentre trade show in Paris. Alongside the FP-1, the strike also used the Behemoth, which is a delta-wing, one-way system unveiled by Culver Aerospace and GLEFA, as well as the Heavy Strike N-196 platform, which was co-developed by the legendary aircraft manufacturer Antonov and Ukrbornprom.
So on to Section 3, Global Aerospace Partnerships. Because designing a drone is one thing, but mass-producing thousands of them, that's a completely different challenge.
Tracing the production timeline really shows how fast the strategy evolved. To get the sheer volume needed for a 1,000-drone swarm, they had to rapidly expand global manufacturing pacts. If we trace it back to 2022, we see massive financial aid packages, like the initial $25 billion from Canada. But watch how the strategy shifts by early 2026. In February, Ukrainian defense tech firm Airlogics signs a massive deal with a German manufacturer. By April, they're placing firm orders for German-made X-wing interceptors. Then comes the major turning point. In May 2026, at the CanSet conference in Ottawa, a historic manufacturing pact is signed. This timeline is critical because it proves that Allied aid transitioned from just writing checks to direct, heavy-duty industrial integration. And just weeks later, in June, those unrestricted indigenous strikes hit Moscow.
This North American pact brilliantly illustrates the core of this whole new defense paradigm. It perfectly fuses hard-won Ukrainian combat blueprints with highly stable Canadian manufacturing muscle. Actually, if you want a deeper dive into the specific corporate players making this happen, we covered the joint venture between Sentinel and Airlogics in our previous explainer. That explainer completely breaks down how these fixed-wing and VTOL variants like the Requiem are hitting the assembly line, so definitely give that a watch later.
But before we go further into the strategy, let's make sure we clearly understand the technology actually being manufactured. A huge portion of these newly assembled fleets are ISR platforms. ISR simply stands for Intelligence, Surveillance, and Reconnaissance. Think of them as the eyes and ears of the battlefield. Systems like the electrically towered, catapult-launched GOR platform aren't always carrying explosives. Instead, they operate quietly, constantly feeding critical real-time data back to command centers to guide massive tactical operations, like pinpointing a specific refinery tank in Moscow.
Moving to Section 4, Evolving Air Combat Strategies. So, how is all this technology actually reshaping modern warfare doctrine?
The crucial takeaway here is a striking strategic contrast. Ukraine's Air Force is undoubtedly gaining strength with Western-donated tech. They're operating F-16s from Belgium, the Netherlands, and Denmark, alongside French Mirage 2000s and Patriot missile batteries. These systems are incredibly sophisticated, but they come with really strict operational strings attached. They are heavily restricted from being used deep inside Russian territory. On the flip side, the indigenously developed tech, like those FB-1 kamikaze drones, represents total strategic freedom. Because they rely on decentralized manufacturing and are super cost-effective, military commanders can deploy them completely unrestricted for deep strategic strikes.
Keep this two-pronged strategy in mind because it is incredibly deliberate. By leveraging decentralized global co-production, partnering with Swiss, German, and Canadian firms, Ukraine is completely bypassing its own local supply chain disruptions caused by the war. This guarantees a steady stream of hardware flowing right to the front lines. And with this unrestricted hardware, they are actively isolating strategic targets. For instance, separate drone campaigns have specifically targeted logistics around the Black Sea, which has successfully created localized fuel shortages in Crimea. Basically, fusing foreign manufacturing with combat-proven Ukrainian design is turbocharging their entire defense posture.
Which brings us to Section 5, Lessons for Modern Warfare. What are the ultimate takeaways from this investigation?
So what can we learn from this story? Well, we've seen how a strike involving over 1,000 uncrewed systems effectively shut down the airspace of a major global capital. And they did it using hardware built not by traditional defense giants in massive, secret facilities, but through highly agile global co-production packs. As the traditional boundaries of defense manufacturing start to blur, it leaves us with a really profound question. Will decentralized drone production become the new absolute standard for the global aerospace industry? It's a huge shift, and you can bet aviation analysts and defense ministers around the world are watching it incredibly closely. Thanks for watching Airflight Space. If you found this explainer informative, leave a like and subscribe for more aviation investigations and air safety documentaries. I'd love to hear your thoughts on this decentralized manufacturing model, so share them down below, and I'll see you in the next explainer.